Good evening and welcome to the Q&A session 4 from the playlist of electromagnetic waves. The topic is the calculation of displacement current, and this session is in continuation of the session number 2 and 3, in which we have studied about the displacement current and the Maxwell equations. In the session number 2, we have studied about the displacement current, and in the session number 3, we have studied about the Maxwell equations. And the question for this session is written here on this board. And the question is, a capacitor made of circular plates, each of radius 12 centimeter and separated by 5 centimeter, is charged by an external source. The charging current is constant and equal to 0.15 ampere. So the displacement current across the plates is, so we have been given here 4 options and we have to select the correct one. So here a capacitor is made of circular plates, each of radius 12 centimeter and separated by 5 centimeter. So the capacitor will be something like this. So these are the two circular plates of a capacitor, and these are separated by a distance of 5 centimeter, and the radius of these capacitor plate is equal to 12 centimeter. Now this capacitor is charged by an external source, and the charging current is constant and equal to 0.15 ampere. So in the session number 2, we have learned that the displacement current, that is ID, is equal to epsilon naught into d phi e divided by dt. Now this d phi e upon dt is the rate of change of electric flux. And in the session number 3, we have studied about the Maxwell equations. So in this question, we will be using one of those equations, and that equation is the Gauss law of electrostatics, which states that the total electric flux passing through a closed surface is equal to Q upon epsilon naught, and mathematically it is written as the line integral of EdA. This is equal to Q upon epsilon naught, and this is equal to the total electric flux, say phi e, passing through that closed surface. So I will be using these two formulas in order to find the displacement current across the plates of this capacitor. So here, this equation, that is the line integral of EdA, is equal to Q upon epsilon naught, which is equal to the electric flux, that is the total electric flux which is passing through a closed surface. So this equation can further be written as EA cos theta, and this is equal to Q upon epsilon naught, and this is equal to phi e. Now here this line integral of EdA is equal to EA cos theta, where theta is the angle between the direction of the electric field and the normal to the surface of the capacitor. Now here the direction of the electrical field will be either this way or it will be either this way, and the normal and the angle between the normal to the surface of this capacitor plate and the direction of the electrical field will be equal to, that is theta will be equal to 0. So this equation can be further written as EA is equal to Q upon epsilon naught, and this will be equal to phi e. Now if I differentiate this equation with respect to t, then I will be getting another equation, that is d phi e upon dt. This can be written as, now here Q is the net charge which is enclosed by that surface, and epsilon naught is a constant. So d phi e upon dt will be equal to 1 by epsilon naught into dq upon dt. So this can further be, now dq upon dt is the instantaneous current. So in this case it is equal to 0.15 ampere. So this d phi e upon dt can be written as 0.15 divided by epsilon naught. Now, the displacement current is equal to epsilon naught into d phi e upon dt. So here, the displacement current will be equal to epsilon naught into 0.15 divided by epsilon naught, and this will get cancelled out. So the displacement current value is equal to 0.15 ampere. That is, the displacement current across the plates of this capacitor will be equal to 0.15 ampere. So in this question we have used two things. First, the formula for the displacement current, and the second was the Maxwell equation, and the equation which we have used was the Gauss law of electrostatics, in which states that the total electric flux to a closed surface is always equal to Q upon epsilon naught, where Q is the net charge which is enclosed by that surface. So by using the Gauss law of electrostatics and the equation of the displacement current, we were able to find the displacement current across the plates of this capacitor. So thank you very much for joining this session. In the next session, I will be coming up with another question, but it will be from the topic of Maxwell equation. So till then, have a nice day. Bye.